So these video notes are going to cover algebraic expressions and formulas. So we'll start with a couple of definitions. A variable is a letter used to represent an unknown quantity. So we see variables a lot in algebra, obviously. The most common one we use is x, right? Sometimes we might use y. One thing I want to bring up is that if you see pi, the Greek letter pi, this actually has an exact value. So pi is in fact not a variable ever, because pi will always and forever stand for 3.14159, etc., etc. And I bring this up especially because in Algebra 2 there's a few more interesting numbers we'll learn about that will have certain letters assigned to them. So they aren't variables, in fact. But x and y usually we use as variables. An algebraic expression is any expression that contains at least one variable. So I could write 3x plus 5 minus 4b. And in this expression, x and b are both variables. The order of operations tells us how to evaluate an expression. And it goes parentheses, exponents, multiplication, division, addition, subtraction. You may have commonly heard the phrase PEMDAS to use the algebraic, or to refer to the order of operations. PEMDAS, right? And this is important because, so say you are trying to evaluate the expression 2 times 3 to the second power, right? So it's important that we use the order of operations for this, because if we do these in a different order, we'll get a different answer, right? So one way we could do this, the correct way to do this would be, first we say what's 3 squared, and that's 9, and then 9 times 2 would be 18, right? So this would be equal to 2 times 9, right? And not 2 times 3 and then you square it. So we'll start with just a couple of examples. So an easier one is evaluate m plus p minus 1 squared if m equals 3 and p equals negative 4. So we'll start by just substituting. So we'll substitute m equals 3 and p equals negative 4. So I'm going to take the expression, and I'm going to substitute 3 where I see m. So now it's 3 plus, and then instead of p, I'm going to have negative 4. Negative 4 minus 1, and all of that is squared. And now we just evaluate using order of operations. So we'll start with inside the parentheses. So negative 4 minus 1 would be negative 5. And that you hear is my cat trying to be in the video. And negative 5 squared is 25. So we have 3 plus 25. And that comes out to 28. So when you say evaluate expression, we really just mean, find the answer. So we'll move on to this more complicated example. So we'll start again. We still substitute. We substitute w equals 4, x equals negative 3, and y equals negative 5. So in the numerator, I'm going to write negative 3. That's to the 4th power. Minus 3 times 4 times negative 5. This is all divided by y to the third power, so that's negative 5 to the third power, plus 2w, and w is 4. So when you have an expression that's a really large fraction like this one is, it's implied, in fact, that the entire numerator and the entire denominator are inside like a large set of brackets. So what this means is you evaluate the numerator and the denominator separately, and then the last thing you'll do is divide. So we'll start by using the order of operations inside of the numerator and then separately inside of the denominator. So negative 3 to the fourth is going to be positive 81. And positive 81, and then 3 times 4 times negative 5 is going to give us minus negative 60. And then this is all divided by negative 5 to the third power is negative 125. And then 2 times 4 is 8. And then 81 minus negative 60, when you subtract a negative, you really add them, right? So that's 81 plus 60. So that is 141. And then negative 125 plus 8 is negative 117. Now, when you have a negative in the denominator of a fraction, really you can just bring the negative out to the front, because what you're saying is just that this fraction is a negative number, right? So it doesn't matter whether you write the negative in the denominator, the numerator, or in front of the whole thing. And then 141 over 17 can be reduced to 47 over 39, since that's not a 39. 47 over 39. Negative 47 over 39. All right. So on to the page 2. We'll start with one more definition. So a formula is a mathematical sentence that expresses the relationship between certain quantities. You've seen formulas before, of course. In geometry, you worked with them a lot. You could have the area of a circle is pi r squared. So r would be the radius. You could have the volume of a cylinder is pi r squared times the height. So a formula, it specifies that you have one variable isolated and expressed in the terms of other variables, right? So what this says is if you know, it's the volume one, it says if you know the radius and the height, then you can find the volume, right? So the last example we'll do today is the formula for the volume of a cone, 1/3 times pi r squared times height, where h is the height and r is the radius, can be used to find the approximate volume of a tornado. To find the approximate volume of the tornado on the right. My advice to you is if you see a tornado, in fact, you should run and then maybe worry about finding the volume. But first, run, find shelter, and assuming that the tornado is a perfect cone, which most of them aren't, we could find the volume of it, right? So we'll substitute in the values that we know. So the volume is equal to 1/3 times pi times the radius squared. So it says the radius is 75, and times 225. So using our order of operations, first we square 75, and that gives us 5,625. And then now that it's all multiplication, we can just multiply straight across. So remembering that pi is approximately 3.14, then the volume of this tornado is 1,325,359. And then since the units and the units for the radius and the height are both in meters, that means the volume we would write in cubic meters, which is written as meters to the third power, but that means a cubic meter. Okay, so that concludes this first set of video notes. Remember, this will be checked tomorrow that you have your video guide all filled out, and then we will stamp that for a completion grade. All right.